Hello everybody, I am Bhavay Goyal. I am a school student studying in grade 10th right now. The problem which we are going to discuss today is singing tournament. It appeared in ZCO 2019. The problem code is SINGTOUR. The difficulty level is easy. The prerequisites are sorting and some observation. So let us directly jump onto the problem statement. So in this problem, basically, the Zero Series Singing Championship is going to start, and Lavanya wants to figure out the outcomes before the tournament even begins. So she devises a method so that she can accurately predict the outcome of a match between any two singers. So she represents various pitches as integers and has assigned a lower limit and an upper limit for each singer. And the lower limit is always lesser than the upper limit. If a singer has a lower limit L and a upper limit U, this means that the particular singer can sing in all the ranges between L and U, including L and U. So let us say if the lower limit is 5 and the upper limit is 10, so the singer can sing in 5, 6, 7 up till 10. So this is basically the ranges in which a singer can sing. So the lower bounds and upper bounds of all the singers are distinct, means no two singers have same lower bound and upper bound. When two singers SI and SJ with bounds LIUI and LJUJ compete against each other, then the SI will win if SI can sing in every pitch in which SJ can sing, and SJ will win if SJ can sing in every pitch in which SI can sing, and some more pitches as well, like, but that's not necessarily. SJ will win even if it can sing in any all of the pitches in which SI can sing. If neither of these conditions are met, then the match ends up in a draw. So let us say that Li is equal to 5 and Ui is equal to 10, and let us say Lj is equal to 3 and Lj, the Uj is basically equal to 12. So basically LJ can sing in 3, 4, 5, means LJ can sing up from 3, 4 up till 12, and this Li can sing, basically the first singer, basically the Si can sing from 5, 6 up till 10. So basically we can see that the second singer can sing in all the ranges in which Si can sing. So basically in this match the winner is gonna be the second singer. And if let us say the LJ would be 8, so in this case basically the second singer can sing from 3 to 8 and the first singer can sing from 5 to 10. So basically the first singer can sing in some extra ranges that are from 3 to 5, means this singer can sing in the ranges 3 and 4 in which the second singer can't sing, and the second singer can sing in the ranges 9 and 10 in which the first singer can't sing. So for this basically there is no particular one winner, so this match will end up as a draw. To just make it a more clear, like we can say that, like let us say if the ranges are, the lower limits are Li and Ui, and the limits for the second player are Lj and Uj. So second player will win if Lj is less than Li and Uj is greater than Ui. It is basically greater than equal to and less than equal to, and basically the first player will win if Li is less than equal to Lj and Ui is greater than equal to Uj. In this case basically the first player is gonna win, and in this case basically the second player will win. And if neither of the two conditions is met, then the match will end up as a draw. This is basically the how she is gonna determine the winner. So there are n singers basically who are competing against each other in the tournament, and each singer is gonna compete with the other n minus 1 singers, and in each match the winner of the match will be given 2 points, and if it ends up in a draw then both the players will be given 1 point each. So we are given basically the lower limits and upper limits of all the n singers, and we have to output the total score of all the n singers. So let us just understand it more clearly by using the sample test case. So yes, this is basically the sample input. So in it basically we are given two singers. These are basically two test cases are given basically, and in the first test case there are three singers, and these are basically the lower limits and upper limits of these three singers. So let us just solve the first test case first. So in first test case n is equal to 3, the limits are 10, 20, 13, 18, 15 and 19. So let us say that firstly these two players are these two singers are gonna compete. So we can see that this 10 is less than this 13, so this can sing in more pitches, more lower pitches than the second player, and this UI is greater than this UJ. So basically we can say that the first player is gonna win from the second player. So let us create an array basically of answer. So this first player is gonna win from the second player, so this he will get 2 points. Now the match will be between these two players. So out of these all players basically we can again see that this li, this lower limit is basically less than this lower limit, and this upper limit is greater than this upper limit. So we can say that the first player is gonna win. So again he will get 2 more points, and then the match will be between these two players. So in these two players we can see that li is less than this lj, but ui is also less than uj. So basically in this case this match is gonna end up as a draw, because like no player can sing in all the pitches in which other player can sing. So basically the both of players are gonna get 1 points each. So the answer which we are gonna print is 4, 1 and 1, and this is gonna be the answer for our first test case. Now let us see our second test case. In the second test case basically we are given n equal to 3, and these are basically the ranges. So the first range is 10, 22 and 13, 21, 15, 20. So the first match will be again between these two players. So in these two players we can again see that this li is less than lj, and this ui is greater than this uj. So basically his first player is gonna win. So again the first player will get 2 points. Let us again create an array. This first player is gonna get 2 points from this match, basically this first and second player match. Now let us say that the second match is between these two singers. So again we can see that this li is less than this lj, and this ui is this greater than this uj. So again this first player is gonna win, so he will get 2 more points. Now the match will be between these two players. So between these two players basically we can see that li is less than lj, and again ui is greater than uj. So basically this player is gonna win, so he will get 2 points, and this player will get 0 points. So the answer of this test case will be 4, 2 and 0. So this would be the answer of this test case. So I guess the problem is pretty much clear to you, that what we have to print and how we have to do. So now let us move on to the observation and the approach how to solve the problem. So the observation is basically like, what we'll be doing is we will just comparing all the lower limits and upper limits separately. So like if we just normally take out the answer of these two singers, then we can see that L1 is like L2 is less than this L1, and this U2 is also less than this U1. So this is gonna end up as a draw. So both the players are gonna get 1 points. So now what we are gonna like, what we'll be seeing is like, we can see that L2 can sing in up to like from 10 ranges. The lower limit of L2 and singer 2 is 10, and the lower limit of singer 1 is 15. So we can clearly see that singer 2 can never be the loser, like he can never lose the match basically from the singer 1, because he can always sing in some more pitches in which singer 1 can't sing. So either there is gonna be a tie, or there is gonna be like singer 2 is gonna be the winner. Only these two cases are possible, because singer 2 can sing in some more pitches in which singer 1 can't sing. And if we see that the upper limit of singer 1 is greater than the upper limit of singer 2, So the again the singer 1 can also not be the loser in any match with singer 2, because the singer 1 can also sing in some more extra ranges in which singer 2 can't sing, like which are from 16 to 90 20. The singer 1 can sing from the ranges 16 to 20 as well, in which the singer 1 can't, I mean the singer 2 can't sing. So basically the singer 1 will win for sure, like either it will win or there is gonna be a tie at least once. And for the singer 2 as well, because of this lower limit, either there is gonna be a tie at least once or he's gonna win. So basically both are gonna get 1 points for each. So like in short, what we'll be doing is like basically we'll be checking if the first player is winning in the lower limit, then we are gonna give him 1 point, and if he's also winning in the upper limit, then we'll give him one more point. So let us say here it would be like 25 instead of this 15. So let us say here it was 25 instead of this 15. So what would happen, like now let's say this singer 2 is winning in this particularly, singer 2 is winning this in this lower limit, so we are gonna give singer 2 1 point for this lower limit. And we can see that he is also winning in this upper limit, so we are going to give him one more point because he is winning in upper limit as well, and he'll get 2 points basically, and singer 1 will get 0 points. And if we just normally calculate it, then the singer 2 can sing in all the ranges in which singer 1 can sing. So singer 2 is the winner. That is why we are giving singer 2 2 points and singer 1 0 points. So basically both the things are same. So this is basically gonna be the observation, and it is the main observation. And if we understand this observation, most part of the problem is like almost solved. So let us see the approach and understand the problem like more clearly. So now the main approach goes as follows. So like first of all, like let us write all these lower limits with their indices. So first of all there is 3, 2, 6, 1, 5 and 12, and their indices are like 1, 2, 3, 4, 5 and 6. So what we can see over here is like let us say this 3, we are on this for like this first player is this 3. So this first player is gonna at least win in the lower limits from this 6, let me check the color, from this 6, 5 and 12, because this first player can always sing in all the limits, like in more limits, like he can sing in 4 in 4 which in which these all players can't sing. This first player can sing in the limit 3 as well, in which all these players, all these 6, 5 and 12 can't sing. So basically the first player is gonna get at least 3 points for all these players, and let's say this player is gonna get 4 points because this player, like this player is gonna win from this 2, 6, 5 and 12. So this second player is gonna get at least these 4 points for the lower limit only. So like what we can do is we can sort the array based on the lower limits. So let's sort the array and write it down. So first of all this is gonna be the like at first, then this 2 and 2, then this 3 and 1, and then this 5 and 5, then this 6 and 3, then this 12 and 6. So we have sorted the array, and now what we can say is like the n is equal to 6 and we are on this first index. We can just run a loop. So our I is basically first of all on this first index. So and the n is equal to 6 basically. So this first player, this fourth player basically is gonna win from all of these in lower limits. So because like he can always sing in the first limit in which none of these player can sing, so we can give him 1 point for each of these, which is basically equal to 6 minus the index of the I, which is basically 6 minus 1. So we can give the fourth player 5 points. So we have given this fourth player 5 points basically. So now let us like increment the I, and like after incrementing our I comes over here, and now like the I is 2. So this second player basically can win from all of these four singers, at least in the lower limit. So we can give this player 4 points because this player is gonna win at least once in the lower limit. So this player is not gonna lose from any of these players. Either there is gonna be a tie or the second player is gonna win. So we can give this second player as 4 points because which is basically equal to n minus this I 2. So 6 minus 2 is basically 4, so can give him 4 points. In the same way, like we can give, now we will just increment our I. Now we can give this first player 3 points. Now we can just again increment the I, and now we can give this equal to, like this fifth player we can give 2 points, and then we can give this third player 1 point, and the sixth player is not gonna win, so we are gonna give him 0 points for now. Now what we will be doing is, like, we can write the upper ranges and compare them in the same way. But like let us just write down the upper limits as well now. So the upper limits are 5, 7, 10, 26, 8 and 20. And like their indices are 1, 2, 3, 4, 5, 6. So what we can say is this 26 is gonna win from all of these other players because it can sing in many other ranges in which none of these players can sing. So we'll be just sorting it again, but like to make it a lot easier, what we can do is we can sort it in the descending order because we want the limit to be greater. Like we can sort it in ascending order as well, but if we are sorting it in ascending order, then we'll have to run the loop from back side. So to make it easier, what we can do it, we can basically sort it in descending order only. So if we sort it in descending order, we are getting 26, 4, and then this 26, then we are getting this 10 and 3, then this 8 and 5, then this 7 and 2, and then this 5 and 1. So what we can see is this fourth player is again not gonna lose from any of these players. Why? Because like he can sing in many other ranges like 21, 22, 23, 24, 25 and 26, in which none of these player can sing. So either he's gonna win out of all these or there is gonna be a tie. So we can again give this fourth player 1 point for each of these. So now again the I would be 1 in starting and the n is again 6. So 6 minus 1 is 5, so we can give him 5 more points to the fourth player. Now we'll just increment our I, and now what we can say is like this sixth player is gonna win from all of these 4 players, like at least in the upper range. So we can just give this sixth player 4 points. Now we'll again increment the I. So now this third player is gonna at least win in the upper range from these 3 players, which is equal to 6 minus this I, the value of I is 3. So we can just give the third player 3 more points. So now we'll just again increment the I. Now the I is over here, so like we can give this I, like this fifth player, 2 more points because he's gonna win from these 2, at least in the upper range. So we have given this fifth player 2 more points. So after that, like what we can do is we'll just increment our I again, and now this second player is gonna win at least once from the sixth player in the upper range. So we are gonna add 1 to this, and to the first player we are gonna add 0, like so. Like after just solving, this is gonna be the answer, and we are just gonna print it 3, 5, 4, 10, 4 and 4. This is gonna be the answer of this, like basically this sample test case, and this is all about the approach. And I hope the approach is pretty much clear to you now. I'll just highly recommend you to just go and write the code by your own once. And now like we'll be just discussing the code. So now let us write down the code basically. So I am just taking in test cases, and like for each test case we'll just take the input of the n, the number of singers, and then we'll just define 2 vectors of like pair of int command. We are using pair over here because we'll need to store the indices as well of like each singer. So lower first vector is, let's say, lower of size n, and the other is upper of size n. Now we'll be just taking the input of these. So let's say we have taken the input now. So now we'll just take in like lower of I dot first, and then upper of I dot first, and we'll just define lower of I dot second to be equal to I, and upper of I dot second to be again equal to I. So in the first value of the pair, we are just storing the like the input, like whatever we are getting. Let's say in here we are getting 10 and all, and in the second we are just storing the indices of that element, like that particular singer. So now we are gonna sort the array basically. Sort lower dot begin, comma with lower dot end, and now we are gonna sort the upper array as well. Now we are gonna sort the upper array in the descending order. So what we can do is we can put this custom comparator greater int over here to sort it in basically the descending order. So now we can create one more vector of int answer of size n again, and we'll just storing all the like answer, whatever the answer is, in this answer variable, like answer vector basically. So now we will just run one more loop, and in the loop what we'll be doing is like we'll just increment the answer of lower of I dot second by n minus I minus 1. So let me explain what we are doing over here basically. So like whatever the index is there, like let us say over here there is it has sorted in like 1 5 8 6, and like the indices are, let's say, 2 3 and 1. So this first person is gonna like in this, like we are gonna add in this 2 in the second index basically. So what it is gonna do is lower of I dot second has this second index, so we are gonna add whatever we are gonna add is we are gonna add in this index basically. So and what we are gonna add is basically the value of n minus I, as we discussed in the approach. So why are we doing this minus 1 also over here? We are doing minus 1 here because here there is a 0 based indexing. So here it is not 2 3 and 1, here it is basically 0 2 and 1, because there is a 0 based indexing. So that is why we are subtracting one more minus 1, because like if we want subtract minus 1 over here, so like here like this index would be 0, 0th index, so it will do 3 minus 0 3, which is like but we have to add 2. So if we just don't do this minus 1, then it will become wrong. So that is why we are doing minus 1 also over here, and the same we are gonna do it in the like upper as well. So upper will be just again incrementing n minus I minus 1, and then we'll be just printing the I, like the answer or the elements of the answer, so with a gap. And after we have printed, we'll just give a line gap, and I guess this should work. Let us just try it out. So here some error is coming, I guess. Yeah, so we didn't have to write that int over here because like we were just using like the pairs and we were putting int over there, so that was wrong. Like, so we are getting a bit some right answer. Okay, so we are just putting over here equal to, like we have to just increase, like we have to do plus equal to. That is why it was coming a bit some wrong. So now yeah, so now the answer is coming pretty right. Now just let us submit the code as well and check if it is working. So let us just submit it and check if it is working. So we have got an AC now. So our approach is working pretty fine. Now let us calculate the time complexity of our code basically. So basically we are running an on loop over here and an on loop over here, and we are just doing the sorting over here. Like, so what we can write is like, we can write, we are doing first of all running an on loop over here, and then we are just sorting it. So n log n, basically the complexity of sorting is like n log n. So it would become the order of n log n, and then we'll just once more we are just sorting it, so it will again add up to n log n. And then we are also running two more loops of size on. So we are just running two more loops and of on. So the time complexity, like we can just see that these are loops are on, these three loops, and this is n log n. So n log n is like greater than on, so like the overall order of the time complexity will become n log n. So basically the overall time complexity of this code comes out to be n log n. So that was all about this video. I hope you liked my explanation. Thank you very much.